Greetings, Saintsmen. We're starting lesson 9-6, which is solving right triangles. Just trying to get this going where I can actually monitor my live stream, which I'm having a difficult time doing here. But let's go ahead and restart this. Okay, so with solving right triangles, we're going to go ahead and review the trig functions, which we have so, ka, toa, age-old mnemonic that your parents and probably grandparents even learned with regard to sine, cosine, and tangent, and the ratios that we use to solve these. So I'm going to give you guys, we're going to start to solve a lot with a little, okay? So this is where we're going in this class. I'm going to give you less information, and we can actually deduce a tremendous number of facts about a figure. So let's go ahead and take a right triangle here, okay? And I'm going to only give you 2 dimensions on this right triangle, which is named A, B, and C, all right? And the only 2 dimensions that we're going to be given is that we have a side of 3 and a side of 4. All right. So the question then becomes, can we solve for other parts of the triangle? Okay. So how would we go about doing that? Well, a few things. First of all, opposite C is what we're going to have here for our hypotenuse. And we have these other 2 legs, okay? And what's nice is that if we're going to start to name these things, right? So we're going to say that 3 and 4, because we would call this segment BC, but we'll have another name for it because it is the side that is opposite angle A. So we're going to also call this guy lowercase a. And then this here being opposite capital B, we're going to call lowercase b. So this C is our hypotenuse, and we have to solve for this. Well, of course, as you guys know, 3 squared plus 4 squared is equal to C squared, which, right, is going to be 9 plus 16 for C squared, or 25. All right? And when we get that, trying to get Twitch reloaded here. Okay. We get that, C is going to be equal to 5. Okay? So, all right. Now, how could we solve for this? All right. Well, we have a number of ways to solve for all of these angle measures, okay? Because we already have 2 of them. We know all 3 of the sides. But the question is, in a 3, 4, 5 triangle, what are these degree measures, okay? And it'll be the same every single time. So let's first of all figure out angle A. So we were given initially 3 and 4, okay? And what we could use here is the tangent. So this is in the original given assumptions, which we know that the tangent of A is equal to its opposite, right? Which is 3, over its adjacent, which is 4, right? The 5 is the hypotenuse. And to find the tangent of A, to find angle A, to get rid of tangent, we're going to take the inverse tangent of both sides, right? It's that button when you hit the second function on your calculator, -1. I'll show you guys real quick. I got a new little extension here on my computer for Texas Instruments. I'm pretty pumped about it. Okay. I think it's this one. So let's make this sign in. I think it'll actually do it for me automatically. So much for show password, right, guys? Okay. So I've got this Texas Instruments extension that's going to be super fun for me to go back to and reference, okay? So here we go. I'm going to have my inverse tangent that I took on both sides, and I have to do that for 3 over 4, all right? These tangents, inverse tangent's going to do tangent, so I have angle A, which is exactly equal to this, the inverse tangent of 3 over 4. But, of course, I don't know what that is in degrees. So we're going to take an approximation. So we're going to take angle A, all right? And I'm going to punch this into the calculator over here, okay? So there's a little extension here. I'm going to say we go to the second button, right? and I hit tangent, it gives me the inverse tangent, and then I have 3 over 4. Then I'm going to close my parentheses, and that's going to be, it says 64.35. Okay? Now, that's incorrect. You know why? Because I already know what the solution is. And I'm look back here, and I already see that I've got some issues here that I'm in the classic issue where I'm over in degrees, right? Or in radians, and I need to be in degrees. So I'm going to go ahead and fix that. I'm going to go to second quit. Okay? And let's try that again. My second tangent, 3 divided by 4. And here we're going to get my correct answer, which is going to be about 37 degrees. Okay? 36.89. All right? So angle A is about equal to 37 degrees. All right? Now, let's find angle B. Okay? Now, wouldn't we be able to just say, okay, well, if this is about 37 degrees, this is going to be the supplement, right? Or the complement, right? So this would have to be 53 degrees. And how do we get that? But we take 90 degrees and subtract 37 degrees. And that should give me 53. Okay? But also, let's verify. And I'm going to say, well, let's use sine. Okay? And let's take the sine of B, which, you know, sine, so, is going to be this opposite 4 over the adjacent, or sorry, over the hypotenuse 5, right? So means sine, which is the opposite over the hypotenuse. All right? So then when we solve this guy, we have angle B, which is going to be equal to the inverse sine of 4 over 5. It's a really funky looking equal sign. Let me clean that up a little bit. So, angle B is about equal to, and let's solve it here, 53 degrees. All right? Let's go ahead and check it on the calculator. It's going to be second sine 4 over 5. Oops. Let's go back here. I have 4 over 2. I can go ahead and correct that. 4 over 5. Enter. And about 53.1. And if you guys can see that if I were to take a more kind of precise 36.89, etc., right? And 50.3.130, the sum of those is going to be very, very close to 90 with that approximation. Okay? So there we go. So we're going to start to now get problems like this. And these are my directions. It's literally just going to say solve the triangle. All right? And you will get something like the following. Let me get my auto shape on here. Oops. Let's go to a black ink. Make this a little bit more elongated. Oops. We're going to do my auto shape. And I have, again, triangle ABC. And I'm being given, this is my dimension of 2. This is my dimension of 3. Okay? And I got to solve the triangle. You guys ready? Now, step 1, when we solve a triangle, I need a solution box in the top right corner. Okay? Because here is where we're going to be showing the 3 missing parts that we don't have. Right now, I need 3 sides and 3 angles, and I have 2 sides and 1 angle. I have the 90-degree angle. Okay? So what am I missing? Well, I have side B, right? Because it's opposite angle B, lowercase. I have side A, opposite angle A, so we put lowercase a. And we can say that 2 squared, because we're wanting to find C. So we're going to say that C is about equal to, and we're going to put our approximations in the solution box, okay? C squared is, C is 2 squared plus 3 squared, and that's going to be C squared. Or 4 plus 9 is equal to C squared. So 13 is equal to C squared. And I take a square root of both sides to get 13 is rad C, okay? Putting it into my graphing calculator. Second square root, 13, and that's going to be about 3.6. And remember, we're going to round our sides to the nearest tenth, okay? So 3.6. Now, we need to figure out what are my other sides, okay? Or what are my other angles? So I need angle A. Oops. I have angle A, which is going to be about equal to something, and angle B, which is about equal to something. So let's solve for angle A. I have the exact answer, which is we're going to solve for here, which is the tangent of A. So from the angle, the opposite, right, TOA, is going to be this 3 over the adjacent, which is this guy 2, okay? So when I solve here, of course, I do my inverse tangent on both sides. Those are going to factor out, or not factor, but that's going to be eliminated. And the inverse tangent of 3 over 2, okay, is angle A. All right, and that's the exact answer. All right, but I need my approximation. So again, I go to my calculator, go to inverse tangent. I take 3 divided by 2. All right, and there, oops, that's inverse tangent of 32, right? That's not incorrect. It looked at what my window said, so inverse tangent of 3 divided by 2. All right, and that is 56.3 degrees. All right, so here, this is about 56 degrees. Now, gentlemen, here's what we can do, is that I can just take the supplement there to find B, and I can just say 90 minus 56, because it's an approximation anyway, okay? And I'm going to get that this is going to be 34, and that's what my answer here is, about 34 degrees. And that's sufficient for me. It's an approximation of an approximation, but that's what we're going to have anyway, okay? Another problem here for you. Let's solve another triangle, and this will be the last one we'll have. And then I'm going to give you guys one that you're going to have to do on your own to get credit in your notes, okay? Oops. All right, so I have triangle A, B, C, okay? And the only two dimensions I have is this side, which is 18.4, and this one, which is 41 for angle A, okay? And let's see what we're going to get here. We need to solve our triangle. So the first thing I need is my solution box. Now, what are my missing parts? Well, I have here, this is lowercase c. I have angle A, all right? So I'm going to need to do angle B, all right? And we'll have an approximation there. And I'm also going to need lowercase a and lowercase b. Okay, so how are we going to go about doing this? Well, luckily we have, you know, through SOHCAHTOA, we can get this now. First of all, for B is going to be actually an exact answer. This one's going to be straightforward. We know B is going to be 49 degrees. Has to be, right? 49 is the supplement that we have when we do 90 minus 41. Cool. So this guy's exact. All right. Now, let's actually solve here. So from the angle A, let's say, I have this and I have this, and I want to find whatever this is right here. So this is B. So we're going to say that the cosine, right, of 41, so from the angle, is equal to that adjacent side, lowercase b, over 18.4. Because remember, this guy's lowercase b, and this guy's lowercase a, right? Opposite capital A, and this guy's opposite capital B. So then we solve. I'm going to multiply both sides by 18.4. All right. So I have 18.4 times the cosine of 41 is equal to lowercase b. All right. And then let's go ahead and punch that into the calculator. 18. Oops. 18.4 cosine of 41. Close my parentheses, and I get 13.88. Okay, so we round our sides to the nearest tenth. So this is going to be 13.9 for lowercase b. Now we do lowercase a, which will be, we do the same thing. We could take the sine now, right? The sine of 41, which is going to be equal to the opposite, which is lowercase a over 18.4. Okay, we have to have two unknowns or two knowns here for our third thing. So then again, multiply both sides by 18.4, and we are done. Okay, sine of 41 is equal to lowercase a. This is my exact answer, but then now I need to fill in my solution box with my approximation. Okay, so again, 18.4 times the sine of 41, which it gives me 12.07 or 12.1 when I go back here to fill in my solution box. All right, so last thing that you guys need to try on your own. This is mandatory. All right, I'm gonna go ahead and give you guys here some auto shapes. Here we go. And this is going to be equal to 7. This is A. Oops, let me get rid of my little auto shape real quick. This is going to be 67 degrees. Okay. This is A, B, and C. And you need to solve the triangle. And then see what you guys do when we get to class, okay? Eager to see. Good luck.